Now let's study the third conic section. It's an ellipse. An ellipse is the set of all points in a plane, the sum of whose distances from two distinct fixed points called foci is constant. The line through the foci intersects the ellipse at 2 points called vertices. The chord joining the vertices is the major axis, and its midpoint is the center. Notice we have an example here of 4x squared plus 9y squared minus 36 equal to 0. Hopefully you can see where the center is, where the vertices are, where the foci, and by the way, we're not going to worry about them, but where the major and minor axes are located. Just look for the color scheme. Hopefully that helps. Let's look at another example. In this case, we have what's called a y-squared ellipse. Notice that its major axis is vertical, whereas on the other example, the major axis was horizontal. We also have the center here at 2 minus 3, so the center can move around. Let's look at the general form. What has to be true to have an ellipse? Well, B has to equal 0 again, but A and C must both be positive or both be negative. So you notice we have 9x squared plus 4y squared or 4x squared plus 9y squared. Now, let's look at the standard equation of an ellipse. The standard form of the equation of ellipse with center HK and major and minor axes of length 2a and 2b respectively, where 0 is less than b is less than a, and you have your two formulas there, x minus h squared over a squared or x minus h squared over b squared. If the center is at the origin, then we get the easy ones. X squared over a squared plus y squared over b squared equals 1. And x squared over b squared plus y squared over a squared equals 1. For an ellipse, a is always greater than or equal to b. All right, some examples of ellipses. Let's start with x squared over 4 squared plus y squared over 25 equals 1. Notice the center is at 0, 0. A is equal to 5. 2a is equal to 10. So the length of the major axis is 10. B is equal to 2. 2b equals 4. So the length of the minor axis is equal to 4. And we call that an a y squared ellipse. I misspoke there, because the larger 25 is under the y squared term. So the major axis is on the y-axis in this case. Let's look at another example. X minus 2 squared over 9 plus y plus 4 squared over 16 equals 1. Again, do you recognize that's going to be a y squared with a vertical axis rather than horizontal? The center is at 2, negative 4. A is equal to 4, so 2a equals 8. That's the major axis length. B is equal to 3, so 2b equals 6. And that's the length of the minor axis. This is, as I mentioned to you, another y squared ellipse. A squared, remember, a squared's always the larger of the two. Let's try another one. This time, let's have it in general form and have to do some completing the square. Now, to read the information, it has to equal 1. So notice I'm dividing everything by 36. We have x squared over 36 plus y squared over 9 equals 1. Oh goodness, we're going to have a good old x squared ellipse here with a center at 0, 0. The major axis will be of length 12. The minor axis will be of length 6. And we have an x squared ellipse. A is under the x squared term. Let's do another example. 9x squared plus 16y squared. Ooh, this one's going to be hard because we're going to have to do some major grouping, some major factoring, and some major keeping track of everything. So notice We put the x terms together, we put the y terms together, we put the 119 on the right. Factor a 9 out of the x terms, add 9 to both sides. Factor a 16 out of the y terms, complete the square and add 16 to both sides. So we get 9 times x minus 1 squared plus 16 times y plus 1 squared equals 144. Now, we have to divide everything by 144 because remember, the right-hand side has to equal 1. It can't equal anything else. Then, in this case, we've got to take that first term and divide numerator and denominator by 9. Second term, divide numerator and denominator by 16. So our center here is 1 minus 1, and a is equal to 4, so 2a equals 8. That's the length of the major axis. B equaled 3, so 2b equals 6. That's the length of the minor axis. And this turns out, as you notice, to be an x-squared ellipse. In other words, the axis is parallel to the x-axis. The major axis, I should say, is parallel to the x-axis. And we have our good old x-squared ellipse.